So we're looking at 211, geometry of roots of unity, and we have a theorem that basically says if n is a positive integer, the roots of the equation x to the nth minus 1 equals 0 are 1, z to the first, z squared, so on up to z to the n minus 1, where z is equal to cis of 2 pi divided by n. Okay, and all this is basically saying is yesterday how we looked at that x to the nth is splitting the unit circle up into n sections, and so our solutions split the unit circle into n sections with a magnitude that matches our magnitude. So it comes directly from solving x to the nth minus 1 equals 0. Okay, so if we let, let's see, let's move 1 over to the other side, then we get x to the nth equals 1, and we'll just let x equal little a cis, I'm going to use capital B just so you can distinguish between the angle and the magnitude. All right, so then our x to the nth, our a cis b is going to replace our x, so we'd have a cis b to the nth power, and 1 is the same as 1 cis 0, because if we plotted 1, we'd be right on the positive x-axis, which means we turn 0 degrees. Using de Moivre's rule, we get a to the nth, multiply the magnitudes, and add the arguments. Okay, so we have a complex numbered polar form, they're equal, so that tells us that our magnitudes are equal. A to the nth is 1, and b to the nth equals 0 plus 2 pi, and I'm going to use k, which is the same as 0 plus 2 pi. K is just k, where k is an integer. If we take the nth root of 1, that is just 1, so our magnitude's 1, and our argument that goes with that is going to be 2 pi divided by times some integer divided by n. Okay, so then our solutions would simply be, okay, we're going to take k equals 0, and so b would be 2 pi times 0 over n, or just 0, so that's 1 cis 0, which is the same as this regular 1. If we did k equals 1, then our angle would be 2 pi times 1 over n, or 2 pi over n. So that would be 1 cis 2 pi over n. Now in the theorem they call that just regular z because that's our first root of unity. And then if we took that and we either did k equals 2, so then b would equal 2 pi times 2 over n, so 4 pi over n, well that's 1 cis 4 pi over n, well that's the same as z squared, because z squared would equal 1 cis 2 pi over n squared. We would multiply magnitude, so we'd have 1 times 1 is still 1, and add the argument, so we'd have 2 pi n plus 2 pi n would make 4 pi over n, and we could keep going, we could keep generating solutions until we got to n minus 1 for our integer to put in there, because once we get to that, we'd be back to going all the way around the circle, and we'd be back to the beginning. If we plotted those on the complex plane, we would see that they make a regular n-gon. So if we had x to the 5th, it would make a pentagon.